Okay, we're live. Bye.
Perfect. Thank you. Have a nice one. And to everyone else, welcome to our reInvent Nomad Deep Dive. I'm Jacquie Grindrod, and I'm a developer advocate here at HashiCorp. And today we have Michael and Gail on the show. I'll let them introduce themselves in just a moment. In the meantime, before we get started, if you have any questions or comments, we'd really love for you to interact with us in the chat. Myself and some of our moderators will be keeping an eye on the chat to bring your questions in and make sure we're discussing that. But as you do, please keep in mind that we do have a code of conduct. And in general, we would like you to be welcoming, inclusive, friendly, and patient. Please be considerate, respectful, and professional. You can review our code of conduct at hashicorp.com/community-guidelines. And with that, I guess, Schmeichel, would you like to introduce yourself first?
Sure. Hi, my name is Michael Schurter. You can probably find me anywhere on the internet as Schmeichel, and I'm the Nomad team lead.
Hey. I'm Gail Fagan. I am the engineering manager for Nomad and a big fan of saving money on clouds. So,
Speaking of saving money on clouds, I forgot to say what we're talking about today. So we're going to be talking about well, in the past we did a 1 million container challenge, and this time we decided to, I guess, double that. Really, I was going to say like up that. I was like, yeah, it is double. So we did a Nomad 2 million container challenge, and I'm not sure who would be best to get started on that. I guess, Michael, I'll just point to you first again. So to my left.
Yeah, sure. Yeah, myself and Nick Athir, we're another Nomad engineer. We're kind of on this 2 million container challenge project that we decided to do kind of the next iteration of the 1 million container challenge that we did 4 years ago now. So that's kind of, lifetimes in terms of Nomad. Unfortunately, Nick couldn't be here today. He did a ton of hard work for this, most of the Terraform, most of the Packer, just a huge asset to this whole thing. He recently adopted a new baby, so he is on paternity leave with his family. And so I want to wish him all the best. And thanks again for all of his hard work. But yeah, we teamed up with the AWS Spot team. They were kind enough to give us capacity, and it was just a fantastic experience. I always joked with our AWS partners that it would be a lot easier to talk about the various things with AWS Spot instances if they didn't work so well, because they just kept working. We would just ask for instances and they would be there. They would keep being there. There were just no issues really. And so if I don't spend much time today talking about AWS Spot instances, it's not because they weren't critical to this, but because they just accomplished everything we asked of them.
just works like electricity.
Yeah.
Cool. So, yeah, I guess one of the things that I think folks have been curious about is we did that. I think it's actually helpful to talk a little bit about the history of this and why we did a 2 million container challenge, because there was in fact a 1 million container challenge, and maybe what the differences are, how this came to be. Kind of, I'd love to hear a little bit more perspective on that.
Yeah. The history is really interesting, and we owe everything about the 2 million container challenge to kind of the history of Nomad. Because one of the most incredible parts kind of about the 2 million container challenge is how little work needed to happen on Nomad in order to kind of meet this new goal. And that's in large part thanks to the initial design decisions we chose ages ago. So to get into the history a little bit more, back 4 years ago, Nomad was, I think, approaching a year old at that point. It was around version 0.3. And Nomad had kind of designed for scale from the very beginning and wanted to demonstrate that. And so they kind of chose this 1 million container challenge across 5,000 hosts. to really show that Nomad is designed for scale. It's pretty easy to demonstrate the opposite, that Nomad scales down well. You can download the single binary off of nomadproject.io, run it on whatever operating system you're running, and it'll run on a single node just fine. You should use less than 100 megabytes of memory. Yeah. So it scales down just fine, but they really wanted to show off all the hard work and all the really key design decisions that went into making it scale up well as well. So that was kind of the initial challenge, and then 4 years went by, and we just were focused on features. We were focused on really meeting a lot of the table stakes for modern container orchestrators. And hopefully with our 1.0 release here, that coincided with the 2 million container challenge, we really met a lot of what people expect from a container orchestrator. And so we decided it was time to redo this. And you can't just redo something like this. You always have to do it a little bit bigger than the time before. And in part, this was to kind of prove to ourselves and validate to ourselves that we had maintained kind of these initial design decisions that allowed Nomad to kind of scale up to these very large clusters. So it was a great learning experience for the entire Nomad team. Yeah.
Out of curiosity, we also got a question around this, around what was the bill like for our 2 million container challenge. I don't know if we can actually give that number, but I'm also curious on what the difference was between the 1 million and the 2 million. So.
Oh, that's a great question. The bill was $0 to me. Thanks to our wonderful partners at AWS. Really, I cannot speak highly enough about them. They were a huge asset. Really helped us figure out optimize instance size for the deepest pools of capacity and all that sort of thing. But
I have a couple of details that we can share. So the way that I'd prefer to put this in context, but the way that we set this up with 3 on-demand instances, which were i3.16 XLs, I think. And so without Spot, on AWS on-demand instances, the cost per hour would have been just shy of $2,000, and our footprint was $634.20. So just in case you're still getting out your calculator, that is nearly a 70% savings.
Yeah, thank you so much for having those numbers handy, Gail, because that's really, you run a container orchestrator in large part to save you money. That's what bin packing is all about. That's what making sure that you have your systems kind of running on the minimal amount of spend possible. And so Spot is just such an ideal place to run your workloads. And so it was really exciting to be able to demonstrate that's completely feasible and has really, really big cost incentives.
I think we've talked a little bit about using Spot, and like the past life practitioner in me is like, oh, I want to go back and do that in previous jobs and save money. My managers would have been so happy, but here we are. It's too late. But what else did we do? What else did we use to accomplish this, or what else happened or that we used? That was a great question, but I think you get what I'm saying.
Yeah. So we used all the standard HashiCorp tools, like I mentioned before. Terraform, Packer was in there. Terraform stood up the basic infrastructure. We used AWS autoscaling groups, ASGs, to actually spin up the Nomad clients. For anybody not familiar with Nomad, to give you the 30-second version of the terms I might use, Nomad servers are the schedulers. There's 3 of them. There were 3 of them in this particular instance. In the original C1M, we did 5 of them. Things were a little more CPU bound back then. We can get into that if desired. But you have an odd number of them because they form a raft quorum. And so an odd number allows you to lose one, and things just keep trundling along just fine. So let's see. So those are Nomad servers, schedulers. Then when I say Nomad clients, those are what actually run your workload, are the Nomad clients. And so that's what we had 6,100 of is Nomad clients. We confuse ourselves with our terms sometimes too, so I apologize. But the clients were all spun up with an AWS ASG. We just told it how much capacity we wanted, and we told it what the instance types we preferred were, and weighted them according to amount of memory available, and then just asked for a total amount of capacity. I think it was 18 terabytes of memory total, if I remember correctly, and then just sat back and watched the nodes come online. The image that we used and created with Packer baked Nomad onto the image. So as nodes came up, they used console to automatically discover where Nomad was running or where the servers were running. So that way nodes could register themselves. And so it was kind of fun. We would just hit Terraform apply and then sit back and watch a little graph. I think we even shared it in the blog post. Yeah, I might as well give something visual here. So this this registered nodes in the not the blog post, the C2M content.
Well, I think you have the wrong thing shared, because I see a document.
Speaker notes. What are those?
How does Zoom work?
That's okay.
Hey,
We're all good. There you go.
So yes, registered nodes. This is what we sat back and watched after we hit Terraform apply. And as you can see, the nodes just kind of scaled up and online, and that was all thanks to the ASGs. And then once we kind of hit the desired capacity there toward the end, we had a test harness called Journey that we wrote for this. And oh, actually, yeah, I have that. That's just right here in the C2M repository that we published. Just a little Go program, submits Nomad jobs, waits for them to be running, and gathers metrics after it. So that's kind of how the test went and worked. And then Terraform destroy at the end. So it was a pretty standard, boring workflow. We obviously had to do a lot of iterations on the test and that sort of thing. But on the day that we did the final, it was just kind of a 45-minute deal where we hopped on a call, typed Terraform apply and a couple other commands, and then went home for the day. It was kind of a boring finish to an otherwise very exciting project.
Awesome. So there are actually a couple of questions. Jackie, I'll hand that over to you, because I'm looking at stuff coming in here and it's pretty interesting, and I'd like to know those things as well.
I know, same. I was like, oh, we're putting those in. So the first question we had come in that, well, I mentioned in chat too. We got another question about lessons learned, and I mentioned in chat that we're going to come back to that one, and kind of made a joke that, as you might have just seen, that's our next category, but that's okay. We all make mistakes. The first question we had come in was, what can you tell us about the resilience of the services running on multiple regions with spot instances? And are there any objective metrics that you can showcase around that?
Yeah, that is exactly the question we wanted objective metrics around and failed to, because everything just worked. In the initial 1 million container challenge, we had some servers go down, they got replaced, all that sort of thing just worked. This time around, there weren't any interruptions. So stay tuned on that. I think we're gonna continue with future tests in the future, and our goal there would be to let the cluster run for a longer period of time in hopes of actually experiencing some interruptions and demonstrating both AWS's and Nomad's resiliency in those situations. But kind of the other thing that was surprising is we decided to do spread the cluster over 10 AWS regions. And I say AWS regions because there was only a single Nomad region. The difference in terms here being, I'm sure you're all familiar with AWS regions, but a Nomad region is kind of a logical Nomad cluster. There's 3 of those servers per Nomad region, or 5 or 7 or whatever you want to run, 1 even. And that is kind of the unit of scheduling for Nomad. So we could have run 10 Nomad regions, 1 for each AWS region, but that really wouldn't have shown the Nomad scaling characteristics we were looking for, because it would have been like running this test just 10 separate times. So we decided to go with this global, single global Nomad region. The main hiccup that we hit with that is we have a connection limit, a per address connection limit that we added to kind of prevent denial of service attacks. And because we had deployed these other regions as behind a NAT, behind network translation, address translation, they all looked like they were coming from the same IPs. Our DOS protection has a limit on the number of connections per IPs. So we would start rejecting all of these perfectly normal clients. There's a variety of solutions to that. We could have given all the clients public IP addresses. That didn't feel right. There's other ways you can kind of slice and dice the network translation that happens. But we just chose to disable the limits for the sake of the test. We did use mutual TLS. Everything was encrypted. Everything was authenticated throughout the entire test. So we felt fine about the security of the test. And so we just disabled those limits to kind of get around that. And that's actually something that's probably important for users who might want to duplicate this sort of architecture, because those limits are set in place kind of conservatively, as a protection. And so if you do run this sort of global multi-region setup where clients are behind a NAT, then you'll need a similar setting. One kind of interesting characteristic of Nomad, and then I'll let us move on, is we can run clients behind a NAT because they communicate to servers, but servers do not try to create connections down to clients. And so that really simplifies your network topology. You can spin up a client kind of anywhere in the world, in your basement, in your data center, wherever, and it will connect up to servers. And then all communication between servers and clients happens over a bidirectional RPC over that connection. And so it really simplifies the network topology. Makes a lot of management a lot easier. And it made it so we started with 3 regions initially with the C2M test. And when we decided that it would be easier to kind of get the capacity we were looking for if we went to more regions, it was copying and pasting a few stanzas in Terraform, and then we had 10 regions. That was, kind of the extent of it. So it was really easy to scale it all up.
Somewhere Terraform DA is like, did you just say copying and pasting? Sorry.
I have to admit, the Packer images are the same way. I'm not the best at these tools. It's always so sad. People always expect HashiCorp employees to be experts at all of our products, and I am not. I'm sorry. So the Packer, if you do try to replicate this yourself or want to build the Packer images, just remember that you need to manually build them in parallel. We did not properly set it up to be automatically built in parallel, and they'll take about 2 hours to build if you just do them one at a time versus taking about 10 minutes if you do them in parallel. So there's a little tip for anybody.
That actually answers one of the questions that I feel like we missed or we just touched on, which was what are the biggest learnings and what was the biggest takeaway from this multi-region setup? And certainly building images in 10 minutes rather than 2 hours. Sounds like it fits the bill.
Yeah, it's really surprising the sorts of things that cause issues once you start scaling things up. Things that you can do through copying and pasting, you stop being able to do via copying and pasting at certain scales. I think to kind of really dive deep for a second to one of my favorite kind of technical learnings from this, and I want to give a lot of credit to Alex Dadgard for really kind of spotting the root of this issue, is while testing some earlier iterations, we were just not getting the performance that we were looking for. We've added tons of features since the initial 1 million container challenge. We did not expect to match that throughput exactly. That wasn't even our goal. A lot has changed since then. We just have a lot more features since then. But we thought we ought to be able to get close. And we just weren't quite getting there once we went to the full scale tests. And so in investigating that, Alex noticed that we were spending a lot of time processing these update alloc requests. And what those are is an alloc or an allocation, which is really confusing because we say Alex and alloc a lot, and one is a person and one is a technical term. But an allocation, the technical term, is an instance of your container placed on a node. And so a job is kind of Nomad's unit of scheduling. When that gets scheduled, it creates one allocation per instance. And so what happens is these allocations are placed on Nomad clients, and the Nomad clients then inform the servers, yes, it's running, or no, it's failed, or whatever the case may be. And that's all through this update alloc RPC. Because this update alloc RPC is, every client is calling it quite a bit. It has batching on both the client side and on the server side. And so we were a little bit confused why we were seeing this, extremely high load due to that. And actually, here, I have the PR right here. Let's see if I share the right screen this time. Oh, I think I did it. So this is the PR that came out of that, and it took me like 2 tries to even come up with any sort of like reasonable way of explaining what's going on here. And the actual code change is far, far smaller. So here, side by side is not great, is it?
Are folks able to see this, by the way? How's the text look?
I'm also just going to drop a link to the URL we're sharing in chat right now, too.
That's.
Oh, yeah, thank you. So yeah, this is code in the Nomad client. And what makes this super interesting is that in order to optimize scheduler throughput on the servers, we ended up changing code on the clients. And it just really demonstrates kind of the delicate nature of distributed systems. And especially at scale, the behavior of clients has just a huge impact on the performance of servers. And so what we discovered here is that this is our loop for how often this update alloc. And if you quick
zoom in a little bit more.
Yes,
Sorry.
I can.
Current comments are very small. It's pretty small, but also very hacker with that dark mode.
Oh, right. I gotta always do dark mode. Yeah. So this is in the client. This is where we call that update alloc. It's on a timer so that we can batch up these updates and not just call it once per update. And the real win of that batching is that allocations often update rapidly when they're starting up. And so, for example, we used our Docker runtime. Nomad supports a number of different runtimes from VMs to Podman, Containerd, but for this we use Docker because it's still our most popular runtime. So the Docker runtime has a lot of updates when it's first starting up a container. We tell you when we're downloading an image. We're telling you when we're kind of creating the file system layout for the allocation. Just a lot of individual steps. Each of those is an alloc. They can be milliseconds apart. There's just no reason not to coalesce them into a single update. And so that's the job of this loop. And it appeared not to be effective. And so what we realized is the way that we were resetting the timer, that this 200 milliseconds is how often is kind of the batch size. Every 200 milliseconds, if there's an update, we send all the updates. And what we noticed is the timer was also timing the RPC call itself. The RPC call itself actually also batches for 50 milliseconds. So we lose 15 milliseconds right off the bat. Now that we're running globally, and now that we're running the servers under pretty high load, it's very easy for an extra 150 milliseconds to kind of get tacked onto this RPC call. And so now suddenly the entirety of our batching period is spent calling this RPC. That by itself wouldn't be an issue if we didn't also collect the batches in this same loop. And so if you're new to Go, what's happening here is in this one select statement, we're both receiving allocation updates internally within the client to perform that batching to make sure we're coalescing multiple updates for a single allocation into a single update that we send on the wire. And we're also listening to that ticker, that 200 millisecond ticker, but the entirety of that ticker was being spent in the RPC call. So 200 plus milliseconds would elapse in the RPC call. We would come to the beginning of the for loop, hit the select, the ticker would be available again. If there are no updates at all, we don't bother making the RPC call. We're not that silly. So we would always collect at least one update and then call the ticker again. And then likely call the RPC again. And the Go runtime, when there's multiple case statements in the select, randomly chooses one. And so the odds were we would only be getting 1 or 2 allocation updates per 200 milliseconds. We were running hundreds of containers per node. So to only send 1 or 2 allocation updates at a time meant that we were doing extremely little batching. The servers, which are also trying to batch these, had extremely small batch sizes. We weren't getting any of those performance improvements we would expect from batching. Not only that, but another subtlety of Go is this alloc updates channel we use internally was buffered, meaning the updates that we were actually sending up to the server might be stale due to newer updates being deeper down in that channel's buffer. But because we were processing them so slowly, we weren't sending them. So this slight change to a timer caused a massive performance improvement. And that's because the batching started working the way we intended it to, but also because that means we weren't even having to process a lot of these allocation updates on the servers, because we don't want to process things that are going to be stale a millisecond or two later. There's no functional purpose behind doing that. These updates kind of affect 2 things. One, they're for operators to be able to easily see the status of all allocations in the entire cluster without having to kind of fan out that request to each client that's running an allocation. But 2, they also affect things like deployments that need to know, oh, an allocation has failed on this node, we need to reschedule it somewhere else. So they're important, but they're not important on a millisecond granularity level, which is why this batching works well and why restoring this basic amount of batching was just a massive performance improvement. So it's one of those things where doing less work is kind of always the key to making things run faster, and this really kind of proved that out.
Awesome. So we had another question come in earlier that I just wanted to circle back to, because I didn't mean for us to kind of skip it, but we're not, I promise. And just a reminder for anyone else that's coming to the chat, if you have more questions around how we're doing this challenge or things, like we're watching the chat, we're bringing it in, and we're making sure that we ask those now while we're here. There's still about half an hour left. So next question that we were gonna, next question is, all of this sounds really cool. Was there any churn tests or metrics, such as containers failing health checks, or were we watching the deploy of new versions, et cetera, while we were doing this challenge that we could share?
Yeah, no, nothing failed. Going back to that earlier statement of we were kind of hoping some things would fail, so we'd have those exact metrics. But no, stay tuned. We're going to do more tests like this that focus on a lot more of those scenarios. In a lot of ways, it was great that we had things go so well this time around, because it really let us kind of focus on a very narrow duplication of this earlier kind of benchmark that we set. But yeah, in the future, those are exactly the sorts of things that we're hoping to show. And yeah, AWS is super excited to work with us to show those sorts of things.
Yeah, and I actually think that's one thing that I did want to mention. So the original million container benchmark was really neat, and that was 2 years ago or so. Wow. Okay.
4.
Yeah. So I think the sort of unspoken question is, are we going to have to wait another 4 years for more benchmarking? And one of the things that we're particularly excited about is no. This is. I think we're all really excited about specifically about the pattern of scheduling Nomad on spot fleets, and so this is something that we're going to invest ongoing time into, and just seeing basically how we can stretch scalability and resilience and budget. So.
Yeah, and to tease that maybe just a little bit further is we actually already published some code we intend to use for future tests. I hope Nick, if he ever watches this, isn't cringing that I'm showing this. Don't use this code in production. There's a reason we didn't, call this out otherwise, because it's definitely, we tested it, in the C2M, but it is not up to HashiCorp standards yet of testing and documentation. It has none. But basically what this is this is a Nomad system job that Nick just really quickly created that runs this tiny little Go binary. Yeah, and you can kind of see probably from this comment exactly what it's doing. It watches the AWS Spot APIs to know when an instance is about to be terminated, and it gracefully drains itself. So we definitely played around with this. It worked great. We're sad it didn't make it into the final results, but we have it ready to go for the next tests.
Yeah, I'm excited to see that. So speaking of that, one of the things that that I notice here is running clients in multiple AWS regions from a single Nomad cluster. That our best practices, that doesn't quite align with our best practices. So I was wondering if you could provide a little bit more insight into that.
Yeah, Nomad, yeah, kind of like I was alluding to before, Nomad tries to be really flexible about your kind of cluster topology. Whether you match AWS regions 1-to-1 or not. Nomad is not opinionated about that at all. Now, our best practice is not normally for people to scale a cluster, a single Nomad region globally. And that's just kind of largely due to we have a great federation story for doing multiple Nomad regions. You can do deployments now across multiple Nomad regions. So we really want people to use that because that has a much better failure domain story, right? If you lose a region, you just lose that region if you're running one Nomad region per AWS region. With this kind of global Nomad region, if US East 1 had issues, God forbid, but let's just pretend that in some future it has issues, that means your entire cluster is unavailable for scheduling. Now, I want to be clear, it's unavailable for scheduling. We do not stop workloads in this case. Nomad tries to be very careful and always biased towards keeping workloads running until it's told otherwise. So if you run a full global cluster in 10 regions, but all of your Nomad servers are in US East 1 and US East 1 goes down, none of your customers would notice. Your site would still be available. Your containers would still be up. You would be unable to deploy changes. It would be a scary, dangerous time, and that is why we recommend against it. But you should be able to see yourself through to the other side.
A bold claim coming in the next Nomad challenge: 4 million containers. I'm just kidding. I'm not promising anything. I'm making a joke. I'm so sorry, viewers.
I'm hearing all this, and I'm thinking about just some of the edge and resilience challenges that I've faced in the past as a practitioner. So this is super exciting. Go ahead. Sorry.
No. I was just gonna say, yeah, it's one environment variable. We just change that, rerun the test harness. We'll see what we can do. Yeah, I mean, there's so many exciting dimensions to test, right? I think we're trying to be careful as a team. Like, it's always fun for us to just keep bumping that number up and being like, look at this great big number. And it's like, but that we need to be careful because we know at the end of the day, this is not the most important thing to people. The most important thing are things like resiliency, are things like being able to take advantage of the massive cost benefits of Spot instances over on-demand instances. And so we'll see if I can quick sneak in a bigger run, but I think our goal will be to really focus on more realistic kind of use cases for future runs.
Mm-hmm.
So speaking on that layer of kind of like everything underneath it and focusing on that, let's talk about IPv6. So When we had a question come in
Right.
earlier. Oh yes, I know, I'm good at transitions. Thank you. Wondering if we could have avoided the NAT/DDoS mitigation by using IPv6, and are we compatible, we being Nomad, with IPv6 and dual stack?
Yes, Nomad supports IPv6. So that is absolutely something we could have investigated. I it didn't come up, and that's probably because the NAT direction was just there and fairly easy. Yeah, shoot. Nick might have more details on that. Sorry that he couldn't be here today, but yeah, I think IPv6 would have worked just fine. It's very hard for me not to get tricked into going on a rant about how much better everyone's lives would be in the container space if the whole world just supported IPv6 natively and well. Because boy, that would make everyone's lives a lot easier. That is not the world we live in. But that being said, I don't want to place any blame on AWS because we just absolutely did not even experiment with that route. We set NAT, Internet Gateway equals true in Terraform, and hit run and ran into the connection limit and set connection limit to off and hit run again, and it all just worked. And that's kind of the extent of the effort we put into the network topology.
That might be an interesting direction since we're going to be continuing down this path to try this with sort of thinking about v6 more at the fore. So
yeah,
so to say that I did not mean for that to be anything resembling a bad pun, but yeah, just with that in mind, might be an interesting direction to pursue, because I'm curious about that too. It does.
Yeah.
Just gonna shamelessly plug that this is a great time to ask some questions for any viewers in the chat, because we're running into just a couple remaining. So it won't take as long for us to get to your next questions, basically. The next question that I'm curious about is, these are really cool to do. And as you mentioned, our version 1 was 4 years ago. How long do we have to wait for the next one? Is it going to be like another 2 years, or?
Months. Yes, very small single digit number of months for the next kind of report in this. Yeah, it'll be interesting to see what cadence we kind of land on. We definitely we know what's coming up next. That'll be in the new year, but not too far in. But other than that, we kind of have a lot of road mapping here yet to figure out about the new year.
And just following up on that, this is also just me asking. I feel like I always ask these questions that I could have asked offline. And I'm like, now that we're here, are we planning on doing any kind of we've had a lot of questions today about metrics. Are we planning on doing more reports or releases on what those metrics looked like for people who want to see how it actually kind of played out when we did it?
Should I just share some metrics? I have a tab.
I mean, if you've got a tab.
I've got a tab. Let's see if I share the right tab. This is always such a nerve-wracking part for everybody at HashiCorp. All right. Do people see Datadog?
We do see
Yes.
Datadog.
All right. You would think I didn't live in Zoom every hour of every day. I do, and I'm just still temperate. Anyway, as you from the title of this dashboard, this is from Alex Dadgard. Here, let's see one in Scratch. I wasn't even brave enough to put my name on mine. Datadog is not my strong suit. Oh, and that's not the right time frame anyway.
Oh, there.
So anyway, back to Alex's. Alex's is pretty. I don't think there's too much in mine that's different. But yeah, so we use Datadog to collect the metrics. Nothing, really special about our Datadog setup. I think the only kind of unique thing we did is we only put the Datadog agent on a small percentage of the clients. This test was not really about client performance. The containers we were running didn't actually perform any work. We did a couple experiments with them, doing silly, figuring out prime numbers and that sort of work just to synthesize it. But it didn't add anything to the story, and it was just kind of a distraction from our main goals. So clients are basically ignored from metrics and from the results. All we were kind of care about is they accepted the work and got it running, in an actual Docker container. Outside of that, everything we're looking at here is server scheduler metrics. And how many hours do we have left on this for me to describe each one of these? Because there's a lot here. Let me see if I can like call out an interesting one really quickly. I mean, no, this job summary running should look really familiar. This is, not the graph that we used for publication. That journey tool generated the graph that we used for publication, but this is the same metric. So we could kind of monitor that as we were going here. What else is interesting in here? Yeah, this alloc requests versus running. Again, that graph should look awfully familiar to the other ones. A lot of Raft specific ones. Oh, here, this is probably a good graph to show. Although we published these as well. So in the 1 million container challenge, they were really CPU bound on the schedulers. And a large part of that is due to Nomad doing optimistically concurrent scheduling. It's a mouthful. Basically, the idea is each one of the servers is in the sense that they all run the same code, they all receive the same messages, they all write the same state to disk. If you lose one of them, the other two are identical anyway, so great, whatever, those two can take over. You spin up a new one, it becomes identical, great, whatever. However, we also have the scheduling pipeline within these servers. They aren't just a database. They also perform scheduling operations. And so for that, we have this queue. We call it the evaluation broker is built into the servers. And every time you register a job or every time a node goes down or comes up, we schedule an evaluation. And the evaluation is just kind of our term for a scheduling event that needs to be processed. Any server can pick up and try to handle and process that evaluation. And so they're all doing it in parallel against the same view of the cluster. And there's a lot of tricks we pull to try to ensure that there won't be conflicts in the resulting placements that they make. But obviously there always might be, especially if you're using the bin packing algorithm, the default scheduling algorithm with Nomad, and you have a homogeneous cluster and you have a homogeneous workload like we did. That's very unrealistic. That's one of the most unrealistic things about our test is that our workload was 1 million completely identical containers.
And yeah, sorry.
Yeah.
So there's actually a couple of questions about that, and this is I didn't want to interrupt you, but is it okay to interrupt you?
Yes.
Awesome. So we had a couple of questions around the same theme, which was real world performance. So there's one question about whether the next challenge could include as a workload some sort of DB writes or some sort of write activity as opposed to just scheduling. And I know we've discussed a number of things that the next challenges can include and the next set of benchmarks. So that's one interesting thought.
Yeah, for sure. A variety of workloads would be great, especially stateful workloads, because hey, we support those now. Nomad, back in the 1 million container challenge days, basically did not support stateful workloads without a lot of effort on the part of an operator. But we have a lot of great support for that now that we could absolutely show off.
And there was another question. I'm sorry, Jackie, am I stealing this from you?
It's fine. Carry on as you were.
All right. So million containers is cool, but how do I scale for increased numbers of hosts? And how will the heartbeat scheme work if there are, for instance, 20,000 hosts? And I can't answer this, but I can preface the answer with, I know that we have installations that are quite a bit larger than that. So with that, I will hand this to Schmeichel for actual technical answers.
Yeah. So while this is actually a great segue, because while the homogeneous nature of the work we were scheduling was not realistic, like let's not pretend, the number of nodes we were using is actually lower than some of the clusters we know exist out there in the world for Nomad. So we weren't pushing the limits of Nomad's ability to manage nodes. That would be an interesting thing to push someday. Let's see. I think I can just close the metrics. Yeah. So, oh no, I lost my train of thought.
So
let's see. We have people on much larger scale nodes. Oh, as far as how Nomad handles scaling a cluster size, as far as the number of nodes is concerned, that's probably worth touching upon, kind of like what to monitor. And for that, I should show the memory graph that I just shut down. So we had 6,100 nodes registered with Nomad at the beginning of these graphs. These graphs start after all of the clients were registered with the servers. And so you can kind of, if you squint, I know that's probably super tiny for everybody, but it's 3 gigabytes of memory. Each of the servers was using 3 gigabytes of memory to hold 0 jobs, 0 containers were running, but 6,100 nodes were running. So then once we kind of scaled this test up, and this graph is published, so you can go see that in the doc over here. But memory usage scales with number of nodes and with number of jobs running. And so by the end of the test, we were up in the 70 to 90 gigabytes of RAM range. So, you know, these are big servers that we were using, obviously. They had literally hundreds of gigabytes of RAM left to go that we could have used. Clearly, we could support much larger tests to worry about RAM at all. But, you know, this is what you can kind of expect to see for Nomad workloads. Your scaling characteristics should be the same. It's very dependent on number of nodes and number of allocations, or number of, you know, amount of running workloads. So memory is a good thing to know about and monitor and be prepared to scale your servers around. Servers can be scaled by spinning up a new, bigger one, letting it join, removing old ones, repeating that for, you know, all 3. They can be done in place. We should have a very resilient story for however you want to upgrade your servers, should you need to do that. But monitoring memory as you scale up a cluster is critical for that. For heart beating, because you mentioned heart beating, and then I'll shut up. Because the heart beating story is one of these things that Nomad did before I joined the team. The 1 million container challenge was right before I joined the team. So this was a super early design decision that has just been of critical importance to Nomad ever since, and we rarely have to think about. But heart beating is when the clients tell the servers that they're still alive. And that's because the servers need to know whether or not to reschedule workloads on clients that may have crashed or are partitioned or unreachable, that sort of thing. So there are periodic heartbeats. Scaled, those heartbeats can become, if you don't want to be having 6,000 nodes heartbeating every millisecond to you know, let the servers know they're alive, and causing a whole bunch of extra load. That actually, one thing we did experience in an earlier test run is saturating the servers with we didn't provision enough capacity for them, and so saturated their CPU to such an extent they couldn't even keep up with heartbeats. And so the heartbeats would start getting treated as those nodes being gone, because the servers don't know if it's their fault or the client's fault. And then workloads started getting rescheduled, and you just had this horrible cascade effect of work getting rescheduled, which causes extra load on the servers that were already failing because of the extra load on them. And that's why you want to monitor CPU usage and memory on servers. Should scale, you know, linearly with your workloads. It should be really easy to monitor and not fall into the trap that, you know, we fell into when we just hammered it with a huge synthetic workload. Because it can get messy when things get fully overloaded. But that heart beating that we designed initially, the servers tell the clients how often to heartbeat. And there are some tunables around this. We did not tune them at all. The defaults should work for a wide variety of use cases. And so as more nodes come online, the servers tell those nodes to heartbeat less frequently. or tell all nodes to heartbeat less frequently. The trade-off here is that it will take longer for servers to reschedule workloads on a crashed node. That should be in the order of single-digit seconds, hopefully hundreds of milliseconds, probably single-digit seconds, or double-digit seconds even. Yeah, probably, especially for this cluster size. Well, that would have been a fun thing to graph. But yes, good subject for a future test. But yeah, so as your cluster scales, you are kind of increasing the time that it takes to notice that a client has gone down. Hopefully your kind of replication factor, how many instances of a job you have running at those scales up as well. So a single node going down doesn't have as big of an impact. But yeah, it's all considerations, and there's tunables for all those things depending on the tolerances of your particular workload.
Cool.
Just wanted to note that I always love when we're doing office hours and we have like coworkers or community members that are sharing things behind the scenes, like, oh, you're talking about this, but did you know this really cool fact? Because it's always great. And an instance we're having of that right now is that we're actually, well, I'm finding out in a back channel that we do have practitioners who are scaling using auto-scaling groups, and the numbers that they're using are upwards in the tens of thousands. And while they're doing that, they're also doing things like scaling in and out the thousands of nodes at a time with spot instances, claiming things back and then rescheduling them out. Because again, you do have that short-lived instances, and I want to talk to them. So if you're watching, please reach out to me. But yeah.
If we could get them to publish the next blog post, that would allow me to go and focus on something else for the next blog post. We got a lot of ground to cover, so let's work together here. We can cover it all. Yeah, that's fantastic. Thank you to whoever is sharing in there. I don't have that window up, but yeah, I never remember what we can and can't share in this sort of thing. So even though I share the wrong screens all the time, I try not to say the wrong things. But I'm glad they're sharing those numbers.
Yeah, I was like, if I'm vague enough, it's okay.
Yeah,
it still illustrates the story.
And I think that was what I was thinking of. It was quite a bit larger than the number of nodes we had. So those are the types of installations that I'd had in mind.
And on the next challenge, idea suggestions, we just got another one that says it'd be really cool to have Chaos Monkey running amok and showing how Nomad handles various failure modes. I would love to participate in that.
Yes, that would be
like my dream goal. But we're closing in on time, so I'm going to move to the next question that we got in, which was, I saw some Podman systemd units in the Packer configs. Were we planning on trying to run a lighter run C? Oh, is it run C or runk? Oh no. Anyway, tool like Podman for this. Well, it's funk.
I love it. Podman, yes. I love that people are poking around in those things already. Yeah, there's a lot of little hints at ideas that we had still in the source code in there. Yeah, there's kind of so many dimensions to play with. Podman was one of them we were considering experimenting with. We didn't have time, so no. What you see in there is the extent to which we made progress on that. Nomad has there's a container D driver from Roblox that I'm tempted to just say like, this is official, let's all go use it, but no, don't. I'm not saying that. We need to like do some more testing of our own first. But no, I'm super excited about the variety of drivers we had, and I'm sad that we couldn't do a wider variety in this test. But that would be fun in the future. What was the other thing that we were going to play with and didn't? Oh, ARM. Amazon has these amazing Graviton instances. Nomad supports ARM. We could have run this whole thing on ARM. We could have done a mixed cluster. That would be super fun to do in the future. Run the servers on ARM, run the clients on Intel and AMD. Like, yeah, there's a lot of fun dimensions to explore. Windows, there might be a couple mentions of Windows. We dropped our Windows ideas pretty early, just as we were trying to shed scope, right? Everybody hopefully on this call understands shedding scope. But yeah, our E2E test suite runs a mix of Windows and Linux servers and schedules across them. So that's absolutely a dimension we could add here. One of the reasons we did do, excuse me, we did not do, some of these dimensions is because C1M was very scheduler focused, and we wanted to stay true to that in C2M. The scheduler doesn't care about Windows versus ARM. It doesn't care about Podman versus Containerd. It's all opaque. I need this many resources. Where do I find them? And so we really wanted to focus on that this time around, but that just means we have more fun to look into next time.
And then still on to challenges. The last question we had come in, which I'm like, yes, but oh no, where did I scrolled and I've lost it forever. Here it is. Also interested in seeing how this challenge would do compared with Kubernetes performance. Just before we even go into that, I know on my roadmap, it's a plan to start looking at how you would run the same job or services in Kubernetes versus Nomad and getting more documentation around things like CSI. I'd love to be able to add like that metrics portion to it, but kind of, what's your take on this?
Yeah, one thing I do want to make sure to call out is that we just published new documentation on our site about Nomad, comparing Nomad and Kubernetes. We had old stuff and you could like only find it via Google. It was really weird. We have it back now. It's updated. It's refreshed. Check that out. I think it's really great content, really in depth. I don't know anything about Kubernetes performance other than what I can Google, like anybody else can Google.
So one thing that I do want to note about this is that the particular way in which we scaled for this particular test, it's a little bit of apples to oranges because we did something that Kubernetes actually can't do, but yeah, I think it'd probably be possible to set up a scalability test in a way that would lend itself to a little bit closer of a comparison. So
yeah, that reminded me of an interesting aspect of our global Nomad cluster. And one of the reasons why it's not necessarily our best practice is because obviously while Nomad's network topology can handle it, it does complicate the story for your workload's network topology. You don't have a flat network space for your services that are running within Nomad. The good news there is that our console integration should support that completely. The nice thing about Nomad and console being decoupled from one another is console can have a different view of data centers than Nomad does. And so you can have console handle all the service discovery within a single flat network space within a single AWS region. And Nomad doesn't have to know anything about it. Nomad only knows about its global region that looks like a flat network space to Nomad itself. And all of your services should still be able to work. Console has all kinds of neat features for gateways between data centers and all that sort of thing. So yeah, sorry for that tangent, but I did want to call that out because it's another thing that because we were using the synthetic workload, we kind of missed out on that complication of the global story, is that you do kind of have to carefully configure console to give your services the network topology they expect.
Mm-hmm. Yeah, it would be cool to do this with a set of reference architectures or workloads or stacks. So that'd be, I think that's one of the things that's definitely on the roadmap for the future tests that we want to do. So.
Yeah, for sure.
Sorry, I just saw a question come in as I was about to say something else. So I was like, wait, what's the question? So I think this is probably going to be the last question we have because we're at time and then we'll be wrapping up. But the last question we got in was AWS K8s managed clusters have Fargate support. Do we have any plans to do the same or similar for Nomad, or maybe throw some plugins in at that or something else?
It's a great question, and I'm suspicious if someone was put up to that question because we're working with a user right now, actually, and the code is out there. It's public, but we're working with a user on what we're calling remote task drivers, which is effectively a way for Nomad to schedule workloads into Fargate, into ECS. There's an ECS or Fargate driver that you can find on GitHub under the HashiCorp organization. That's still an area of active research. The direction we've taken has some trade-offs, as you have to expect when kind of radically changing how and where you're scheduling workloads. Yeah, things like script health. Well, actually, script health checking might work. Yeah, script health checking probably would work, but there will be caveats. But yeah, it's an area of active research that we really want to support a solution for, because we really think that Nomad should offer a compelling solution for a unified control plane for your services. We don't care where you're running it. We take the scheduler's perspective on the world. It's like we're just looking to most efficiently run your workloads, efficiently and resiliently run your workloads. Whether it's Docker, a VM, Firecracker, that's totally up to you. And we should make them all look the same from a management point of view, especially because that really allows your application development teams to kind of choose the right fit for what they're working on and take this burden off of some sort of infrastructure team to have a monolithic mandate for how things have to look across their entire fleet. Like, that's not realistic. So yeah, we want to be where the users are.
I'm sorry, I'm laughing so hard. I just heard that in like a Disney area, like, I want to be where the users are. And I'm just like, oh no, it's going to be stuck in my head for the rest of the day.
Somebody out there has auto-tune. Oh my, okay.
I was hoping that would work.
This is going to be my head for the rest of the day. Anyway, I guess as we're closing up, because we are at time, is there anything else that you'd like to share with the community about this? And then I'll kind of do a wrap up on any events that we have left coming up after that. Yes.
Boy, I don't know. The community has been great. Yeah, we're just really excited. There's been a real appetite for stories about the 2 million container challenge, and the great thing about the community is both interested in what we've done, but also just real passion for where we could go. And so we're excited to go there together. We know people are there's a lot of anxiety is probably a fair word right now about runtimes, container runtimes again, some switches in ecosystems, and we want to be where the users are. We want to make sure that people are able to use whatever works best for their runtime, whether that's Docker, Containerd, Podman, Firecracker, Fargate. We want to offer the best story in each of those cases. And we also want to offer the best story around things like, networking is still way more complicated in Nomad than we'd like it to be. And so we'd love to continue to demonstrate best practices in that area. Maybe like I was talking about with this global Nomad thing, demonstrating how you would configure your services and console for the best connectivity in those cases. That I think would be a really compelling story. But yeah, there's still a lot we can do to make that easier. So yeah, stay tuned.
Yeah, thumbs up. We look at the reactions on GitHub. So if you see a bug, thumbs up it. Let us know that it's important to you. If there's something that you're stumped about, please head over to discuss, and folks will try to help you out. If there's something that you figured out that is not obvious and you think it needs to be documented, submit PRs or even just mention it on Discuss, and we'll try to make sure that information gets properly disseminated. So yeah, please continue to interact with us, and we want to understand how to make Nomad better for you.
Yeah, so we're getting some great discussions and questions coming in, and we're at time, unfortunately, but I'm sure some of these things, like, will Nomad have like a registry that we can use in the future? These are questions we're getting frequently. We're discussing them, and I'm sure it'll come up again on a future office hours. And I saw Gail make his thing. So what is it? Is that a thing?
No, I was indicating, I was making positive noises about that. I hope so. Let me just put it that way.
I hope so too. I think it would go really far for either new or existing users to be able to scale up these applications or workloads faster. And just, I know, like, as a practitioner, it's really nice to be able to see what other people have done and to either make modifications as needed for my own stack, or to just kind of, I don't know the most about Postgres. If somebody who's done a lot more Postgres has worked with it and has a better idea, I'd rather be able to do something similar to them.
Yes.
I totally didn't mean to tangent there.
Yeah,
I just have very strong feelings about this.
Yeah.
That is something that comes up every day, and we think about it a lot. And as a practitioner, I personally want that. So there we go.
Exactly.
Stay tuned.
Yeah. Yes, stay tuned. I'm sure that 2021, we're going to have a lot of really cool things coming up, and we'll have more of these sessions to be able to talk to you and hear from you. And yeah, just generally looking for good ways to get feedback and ideas for what's next. And speaking of what's next, I'm going to shamelessly put this link in here into chat, which is our HashiCorp community office hours link. I was like, please tell me I have the right thing copy pasted, because I've made some copy paste mistakes lately. And but
quick question. Yeah. So I'd love to be able to answer some of those questions async. Is that where folks would go to see the answers?
Oh, that's a great question. Async, I think right now the best place would be our Discuss forums, which I hope I'm on a different computer. So, oh yes, it is discuss.hashicorp.com. Just making sure before I tell links out. And generally our team keeps an eye on those posts, and we try to have these discussions there.
Okay.
Yeah, discuss.
So we can just, okay, cool. So we can just post follow-ups to questions that we couldn't get to now in there, I guess, also.
Yeah, we could totally do that too. Yeah.
Cool.
Otherwise, so this has been one of our reInvent deep dives. I believe there might, what day is it? Things I don't usually try to ask
Thursday.
live, but okay, it is the 10th. Actually, this is the last reInvent one for this week, but kicking off next week, how fitting. We do have a console Fargate session. We'll have a session with Vault. We're going to have one on the AWS provider with Terraform, and we'll also be doing a Waypoint deep dive. And I think that will conclude our reInvent sessions. And I think for Nomad, next up is probably after the holidays, as we've been pretty busy with the general release and everything that comes with that. But I'm sure we'll have a lot to talk about in the spring. So, yeah. And whoops, I was like, oh no, did I interrupt something? And with that, thank you so much, everyone, for joining today. And as always, we just really appreciate your coming in and joining us and giving us our feedback, your feedback, our feedback, giving us feedback and your questions and just everything. It's always such a delight to work with the community, and I actually love being able to talk with everyone while we're doing this. It's great. So thank you so much, and have a good rest of your week, and reInvent if you're attending. And thank you as well to Schmeichel and Gail for joining me today.
Thanks, Jackie, and thanks everybody for listening.